Okay, hello everybody. This is Dr. Muhammad Bataineh. I'm going to be teaching you today how to solve for this integral. So the integral says from 0 to infinity of 1 over x to the power 5 plus x to the power 4 plus x to the power 3 plus x squared plus x plus 1 dx. So one way to solve for this integral is to reorder the terms in the denominator. We can notice that we can take x cubed plus 1 as a common factor. So to do that, first of all, I would call the integral as I. Okay, so I is equal to the integration from 0 to, the integration from 0 to infinity over, and then first of all, I would reorder the terms as x squared and x to the power 5 together, and then x and x4 together, and finally 1 and x cubed together. Okay, so let's do that. So that would give us x squared plus x to the power 5 plus x to the power 4 plus 1 plus x cubed, and then we have dx and 1 in the denominator. Now, if you can notice, guys, we can take some common factors in the denominator. Okay, so we still have 1 here and dx here. So if we can take x squared as a common factor, okay, then that would leave us with 1 plus x cubed. Okay, plus if we can take x here as a common factor, then that would leave us with 1 plus x cubed as well. And of course, we have 1 plus x cubed at the end. So now we can go ahead and take one plus x, or x cubed, let's say, we can call it x cubed plus 1 as a common factor. And then we're going to be left out with a quadratic term, which is x squared plus x plus 1 dx, and we have 1 here. Okay, and we can make, of course, this shorter because we have simplified it. Okay, so I will call this integral this equation in particular as equation number 1. Okay, so this equation is equation number 1, which is basically I, of course. Now, what we can do is we can do a u substitution. We can let u equals 1 over x, and then we can do the substitution with the limits and everything. But we can do that directly by replacing every x by 1 over x, but we need to multiply with the derivative of that, which is minus 1 over x squared, and also we need to change the limits. Okay, so 0 becomes infinity and infinity becomes 0. So if we do that, then the integration would become the integration from infinity to 0, and everything would be replaced by, so the 1 does not change, x cubed would become 1 over x cubed plus 1, and then 1 over x squared plus 1 over x plus 1, and then we need to multiply by the derivative of 1 over x, which is minus 1 over x squared, and then of course dx here. Okay, good. Now we can multiply, if we want to simplify the integral in a better way, so the negative sign there at the end, we can use that to invert the limits in the beginning, okay, of the integral. So that would give us 0 to infinity again. And then, of course, we can multiply the numerator and the denominator with x to the power 5. So if we multiply the numerator by x to the power 5, we would be left out with x cubed, because x squared is going to cancel with the derivative part at the end. And also, we can multiply the denominator by x to the power 5. We can split it as x cubed and x squared, multiply the first term and the second term. So if we do that, then we're going to get 1 plus x cubed, if you multiply the first term by x cubed, and then we are going to multiply the second term by x squared, so that would leave us with x squared plus x plus 1 dx, and I will call this equation number 2. Now, what I will do here is that I will add up equation number 1 and equation number 2 together. So if we do that, then 1 is going to be added to x cubed, and that is going to be cancelled with the denominator here. So that's what we're going to do here. So now 2i, if we add up equation number 1 plus equation number 2, then what we're going to get is twice I equals to the integration from 0 to infinity over of, x cubed plus 1, okay, divided by x cubed plus 1 multiplied by the quadratic term x squared plus x plus 1 dx. Now the integral is a lot easier. Also, what we can do is this is, of course, can cancel out. This cancels out with this, okay? So again, we're going to be left out with the integral I is going to become half, of course, the integral from 0 to infinity over of dx divided by x squared plus x plus 1. Now, to solve for this integral, of course, we can use the tan inverse substitution. Okay, so the trigonometric substitution by letting, first of all, we need to complete the square and the denominator, and then we can use we can let x after completing the term. So first of all, we need to complete the squares and the square in the denominator. So that would give us half the integration from 0 to infinity, and then x squared plus x. Now we need to add up half the factor of x, now x has a factor of 1. Half of that is half, square that's going to give us 1/4. So the 1 can be split as 1/4 and 3/4. And 3/4 is basically, yeah, let's write it as is now, dx, and we still have 1 in the numerator. Okay, so this can be rewritten as half the integration from 0 to infinity, and then we still have 1 here in the numerator, and this can be rewritten as x plus half, right, squared plus the square root of 3 divided by 2 all squared, and then we have dx here. Now what we can do the tangent inverse substitution. We can of course we can use the direct formula here, but let's do it using trigonometric substitution. So what we're gonna do here, we're gonna let x plus half equals the square root of 3 over 2 tangent of u, okay? So now we can differentiate both sides, so that would give us dx equals the square root of 3 divided by 2 secant squared u du. And now also we need to change the limits. Okay, so let's see what 0 and infinity become here. So if x is equal to 0, then u would become, if we substitute x equals 0, half. Okay, so half would be deleted or would be cancelled with half on the other side. So tangent of u is going to become 1 over the square root of 3, and that would give us, let's do it on somewhere on the calculator. I guess it's 60 or 30, I'm not sure. Let's see. Okay, so we need to find the tangent inverse of the tangent inverse of 1 over the square root of 3. So that would give us pi over 6. Okay, and then when x is equal to infinity, then tangent is going to be equal to infinity, and that would give us u equals pi over 2. So the integral now becomes half the integration from pi, 0 becomes, as we said, pi over 6 to pi over 2, and then we can do the substitution here. The dx, of course, becomes the square root of 3 over 2 secant squared u du. That's dx. And then in the denominator, that would give us 3 by 4 tangent squared of u plus 1. We can take the 3 by 4 as a common factor. And tangent squared of u plus 1 would give us secant squared u. Secant squared u. So now secant squared u can get cancelled with the secant squared u in the numerator. And we're going to be left out with, of course, 1/2 outside. 3 by 4 in the denominator would become 4 by 3 outside, and multiplied by the square root of 3 divided by 2, of course. Now we can do the integration, because the integration, what we're left out with is du, right? Okay, so du would give us u plus c. Okay, I'm sorry, u, the integral from pi over 6 to pi over 2. That's what we need to substitute the limits for. So if we can do that now, that would give us, of course, now we can notice that 4 gets cancelled with this and this. That would give us 1 over the square root of 3, or we can basically leave it as is, or, okay, so 1 over the square root of 3 of pi by 2 minus pi by 6. Of course, if we want to do this, we need to multiply here by 3, and this is by 3. So this is going to be equal to 3 pi minus pi, that's 2 pi over 6, which is pi over 3. So pi over 3, the square root of 3, and that's the final answer. Okay, if you guys like this video, hit like, subscribe to my channel, and follow me here. Thank you. See you in another video.